For these questions, we're going to circle each problem if the number of digits in the quotient would equal the number of digits in the dividend. A quotient is just the answer to a division problem. The dividend is the number that's being divided. And the directions say that you're not going to count leading zeros when you do this. So before we look at some examples, let's talk about why this skill is important. When you divide big numbers like this, you use a process called the standard algorithm. And remember, an algorithm is just a set of steps. In long division, the steps are divide, multiply, subtract, check, and bring down. So there's 5 steps in the algorithm. But when you're doing long division, you have to do those 5 steps several times. And the number of times that you do those 5 steps depends on the number of digits that will be in the quotient. So if you can figure out how many digits should be in the quotient, you can figure out how many times you'd have to divide, multiply, subtract, check, and then bring down. So this is a beginning skill that will help you later with a more difficult skill. So let's look at the examples now. On number 1, we see 6,904 divided by 5. So to figure out how many digits will be in the quotient, you'll start by looking at the first digit, 6, and ask yourself, can 6 be divided by 5? And since your answer is yes, there will actually be an answer for that. So I'm putting a blank here to show where one of the digits in the answer would go. Once I figure out where the first digit of the answer would go, then I know that above every other place, there will be another digit of the answer. And the reason why, no matter what you divide, you can always get an answer, even if your answer is 0. So even if one of these spots is a 0, it would still count as a digit. The directions say don't count leading zeros. And leading zeros would be zeros that are at the beginning of a number. And leading zeros should always be left off. So let's look at number 2. This might help you understand it a little bit better. So when we start our process, we're going to look at the first digit, the 1, and ask ourselves, can 1 be divided by 2? Well, the answer is no. 1 can't be divided by 2. So when you're writing your answers up here, if you were to write an answer, that answer would be 0. And if you wrote a 0 up here, it would be a leading 0 because it would be a 0 at the beginning of a number. So we don't even count that as a digit. And we wouldn't have to do a step from our algorithm for this digit. So what we do instead is we look at it as the number 12. And we ask ourselves, can 12 be divided by 2? And since the answer to that is yes, we would have an answer for that. And whatever the answer would be would go right above the 2. And as soon as we start writing our quotient, we know that every other place would have a digit as well. So this answer would have 3 digits. So let's look at number 3. Now we have 6,533 divided by 3. So we're going to start with the 6 and ask ourselves, can 6 be divided by 3? And yes, it can. So we know our answer is going to start in the thousands place. We also know that every other digit in the dividend will also produce a quotient. So let's look at number 4. Here we have 2,814 divided by 6. So we're going to start right here with the largest place value and ask ourselves, can 2 be divided by 6? And the answer is no. So we know that the quotient isn't going to start in the thousands place. And we're going to have to look at it as if it were 28 and ask ourselves, can 28 be divided by 6? And since that answer is yes, we know we can put our answer right there. And as soon as we get one digit in the quotient, we'll have a digit for all of the other digits in the dividend as well. So for this case, we would have a 3-digit quotient. So on number 5, we do the same thing. We start with the largest And we ask ourselves, can 6 be divided by 5? And since it can, that's going to be the first digit in our quotient. And once we get our first digit, every other digit in the dividend will also have a digit right above it in the quotient. So 6,785 divided by 5 is going to be a 4-digit number. Okay, let's do the last one. 31,248 divided by 4. We look right here in the greatest place and ask ourselves, can 3 be divided by 4? And since the answer is no, we're going to have to look at it as if it were 31. Can 31 be divided by 4? And yes, it can. So our first digit of our quotient, our answer is going to go right above the 1. And as soon as we get our first digit, all the other digits in the dividend will produce a quotient as well. So 31,248 divided by 4 is going to be a 4-digit number. The number of digits you see in each problem are going to dictate the number of rounds of long division you'll do. So for this problem, you're going to do 4 rounds of divide, multiply, subtract, check, and bring down. But this one, you'd only have to do 3 rounds. This one, you'd have to do 4, and so forth. But for these questions, the problem actually tells you not to solve them, but just to look at them and circle the problem if the number of digits in the quotient equals the number of digits in the dividend. So if you see on number 1, there's 4 digits in the dividend and 4 in the quotient, so we would circle it. But on number 2, they're not equal. There are 4 digits in the dividend, but only 3 in the quotient, so we're going to ignore that one. And this one is equal, but this one's not. We have 4 down here and only 3 up here. This one's equal, but this one is not. So you try some of these on your own, and once you understand this, the next thing of actually solving these will be easier. All right, good luck, and if you need help, you can come back and rewatch the video.